Work and energy. We will link work concept in discussion of energy. In front of you, as you can see, name of this lecture is work and energy. Our focus will be on energy. Yes, not on work. Some concepts we will be linking with a discussion of energy. I would like to start from meaning of energy. Yesterday, I was telling you meaning of energy. I was saying that it can be created, no. It can be destroyed, no. So in short, we can say energy cannot be created, energy cannot be destroyed. Yes, it is true. We cannot say that energy is end in object. We cannot say that energy is destroyed. We can't destroy it. No, it is impossible. This is universal truth. This statement where yes, this. Okay. No, this. Energy cannot be created and it cannot be destroyed. This statement is a universal truth. Now you can ask, then what can we do with the energy? We cannot destroy. We cannot destroy. We cannot create it. Then what can we do? So my answer would be only we can transfer. Only we can transfer energy from one medium to another medium. Yes. And now, after little information of energy, we will understand types of energy. We will understand mechanical energy. What would be meaning of energy? It is just capacity. I am saying just, it doesn't mean only few, okay? It has capacity. It is a capacity, not it has capacity. It is capacity to do work. If we have energy, then we can do a lot of work. But after doing a lot of work, we will not have that much energy that we had initially. Are you understanding? It means when we will have full capacity, when we will have full energy, and now we are doing a lot of work, we are applying a lot of force, then do you think same energy will you have? No. No. Answer would be no. Because reason is you did work. You applied force on a lot of object. Your energy converted in your energy. Someone gained your energy because you applied. Here I am speaking because of I have capacity. I am saying I have capacity, it means I have energy. That's why I am able to speak. So where is energy? Inside me. Inside me, I have energy. I can speak because of energy. I don't understand. After few hours, I will not have this much energy that I am using right now in front of you. After few hours, this same energy I will not have. Why? Because I am using this energy that I have. That's why I will not have after few hours this that much energy, this much energy, because I am using, by speaking, I am using my energy. But I cannot say after few hours I will not have completely energy. No, I can speak little. Okay, I will be able to speak something. It means I will have little energy. That's why I will be speaking after few hours. This pattern is telling you, if you have more energy, then you can do more work. If you have less energy, then you will be able to do work less work. You will do less work. This pattern: more energy, more work; less energy, less work. Yes, it will happen. It happens. Okay. One real life which you can relate. In the morning, as you wake up, what do you feel? What do you feel in the morning? In this context, I am talking about. In this context, do you feel energetic? Full energy. Do you feel full energy in the morning? Yes, you feel. And now, at that day, in the night, how do you feel? You would say, no, not that much energy. Not we don't have that much energy in the night. Now question is coming. Why? Why do you feel in the morning full energetic, and why do you feel that you don't have more energy in the night? Why do you? This duration between night and morning, this between gap, what are you doing? Whatever you are doing between morning and night, morning and night, you are what? You are doing work. You are applying a lot of force. And here, when you do a lot of work, then your energy, someone gains, someone else gains, object can gain. When you will apply force on object, then object will gain and energy of you will decrease, and energy of object will increase, because you applied force on that object. Clear? Now, two things we will realize now. If you apply, answer, did you get? Did you get answer of why do we feel less energy in the night? Because of we do a lot of work between night and morning. Between morning and night, we do a lot of work. That's why. Now here, when we apply force on object, then force of our will decrease, and on which object on which we applied force, that object will gain. Energy, because we gave energy to that object by applying force on that object. That is how we are decreasing our energy. That is how that object is decreasing. That object is increasing energy. That is. Are you understanding? So remember, if you are applying force on object, then energy of your will decrease. On the other side, energy of object will increase. Clear? That is how energy of your decrease, and at the night, in night, you feel less energetic. Clear? And remember, SI unit of energy and work will be same, joule. Okay. SI unit of energy will be what? Joule. Now I want to discuss about kinetic energy. I want to discuss about kinetic energy. What is these are types of mechanical energy. Mechanical, which means something is movement. Something is movement. Something is movement. Position, change of a position you can. Something is moving. Position of object will be this right. Okay. Mechanical energy. In mechanical energy, there are two energy. There are two types of energy. First, kinetic. Second, potential. If someone asks to you, these are types of what? You would say mechanical. You say mechanical energy. There are two types of mechanical energy. First is kinetic energy, second is potential energy. Now I want to discuss on first type of energy, first type of mechanical energy, which name is kinetic energy. What do you think about kinetic energy? What do you think? This is question to you. This is question to you. What do you think? In some word, I would like to define it in some word by saying, if object will be moving and that object has kinetic energy. If object is moving, it means that object has kinetic energy. That's it. We can extend the definition of kinetic energy. Logically, not unnecessarily. If object is moving, it means that object has kinetic energy. That's why that object is moving. Clear? Don't worry, it was just a little information about kinetic energy. We will discuss a lot of things related to kinetic energy. We will connect kinetic energy with our examples. So this was a little information. Now I would like to move on where? Potential energy. Discussion of potential energy. Little information I would like to give you. Potential energy, which means a object will be in rest. We will do work on that object. And that object will gain energy. Now that object is gaining energy at rest. Now that object is at rest. We would say we did work on that object. Now we would say that object has a potential energy. Potential energy. We say you have potential. You have potential energy. You will do something crazy in your future. It means you right now you have potential energy and you will do in future something crazy. Same here. Object will have potential energy, and when we will release that object, then that object will work. That object will move. Why? Because that energy had potential energy. That's why that object is moving. Clear? Are you understanding? Are you getting to my points? In this case, you will realize that object is moving and that object has kinetic energy. But in this case, you will realize uh, work work is done on object, and now that object will gain energy, but that object will at rest after after doing work on that object will at rest, but that object will have what? Energy. And now name of that energy would be potential energy. When we will release that object which has potential energy, then now that object will move. That object is ready to be moved. As that object will move, then now we can say that that object, we converted that object into kinetic energy, from potential energy into kinetic energy. When we released that object, then are you understanding? We understood meaning of kinetic energy, meaning of potential energy. We have understood. Now we are able to connect meaning of this, definition of this with our examples, with our real examples. Would you like to say? Would you like to say? But before that, before we move on a real example, let me complete a definition of this two. What? What are you saying? Let me explain. Here, look at here. What will happen? Here, always remember, kinetic energy will depend on mass. Will depend on mass. Okay, it will depend on mass. What is the meaning of this sentence? Meaning of this sentence is what? This is a ball and this is object. This is ball and this is object. A speed is the same. A speed is the same for this. Now this object is coming to hit this object. This object is coming to hit this object. Now what will happen? According to you, from your side, what will happen here? If a speed of both objects are same, then here you can see we are understanding what kinetic energy will depend on mass. If object, this object I'm talking about, if mass of the object is low, is less, if mass of object is less, it means it will have less kinetic energy. Simple. It is very simple. If mass is less, kinetic will be less. If mass is more, kinetic will be more. Are you understanding? Are you understanding? It is very simple. If mass is more, it means kinetic energy will be more. Should be more. If kinetic energy is less, no, mass is less, kinetic energy will be. It also depends on, it will depend on velocity. Yes, it will also depend on velocity. Velocity, which means speed. It has a direction. That's why there is a difference between speed and velocity. It will have what direction? Now here, what will happen? Both is the same. Okay, now mass of both is the same. Now what will happen? Here, if velocity is more, if velocity of this object is more, of course we can say kinetic is more, kinetic energy is more. Kinetic energy is more, that's why it is moving fast. Okay, if velocity is more, kinetic is more. Kinetic is more, it means velocity will be more. Clear? Now if velocity is more, then this will hit on this object very fast. Okay, very heavy. This object will move speedily, rapidly. When velocity of this will be more, and it will hit on this object immediately, and this object will take back step very fast. Means distance of this object backward will be more when velocity of this object will be high. Then, are you understanding what is happening? Here is happening. If velocity will be more, it means impact will be more. That object will hit more on another object because velocity is. Now, one point more we can add. If velocity is more and mass is also more, then what will happen? Then you can say impact will be more. Yes. So this both I wanted to tell you. Now I told you. Always remember, it will depend on mass. If mass is more, kinetic will be more. If velocity is more, it means kinetic energy is more. Now, what is the formula of kinetic energy? Very simple. Just half. Here we have what? Mass multiplied velocity. Just half mass and velocity square. Velocity square. Okay, just half mass into velocity square. Half mass, velocity square raised to power 2. This is formula of kinetic energy. How to calculate kinetic energy? Just use this formula, you will get kinetic energy. Okay. As you know, if you want to know SI unit of this kinetic energy, will be same. What we saw that SI unit of energy and work is the same. And here we are observing it has energy. So of course it should be SI unit of a kinetic energy should be what? Joule. Same. If energy what is coming, then Joule SI unit will be Joule. Yeah. So this is the formula. Just as you know, here we are saying it will depend on mass, it will depend on velocity. It means mass multiple velocity, then kinetic energy. But remember, just half multiple velocity as time. Okay. This is the V added. Now let's see what is the relationship between work done and kinetic energy. Relationship. What is the relationship? Relationship work and kinetic energy. What will be? As you know, work formula for work done will be what? F multiple S. F is a force, S is a displacement. This is the meaning. This is the meaning of work done. Okay. Now, what is the formula of KE? Now here, V square minus U square is equal to 2AX. What is it? Can you tell me what is it? V square minus U square is equal to 2AS. Here, you know, it is an equation of motion. It is what? It is an equation of motion. From here you can find S relation. From here you can find what? S, displacement. From here you can find displacement. Am I right? From this equation. This is the equation of motion. You are already familiar with this. So I wrote this here, this equation of motion, because here, as you know, if formula P is what? MA. It can be written as like that. Now from this equation we can find S. We can find S. This displacement, to calculate the displacement, we will get this. We will use this. So here, in place of this, we are substituting 2A. Here this 1A and this 1A. So we get 5. What do we have? Here you can see. We have this. MV square minus U square. MU square upon 2. This is a change. This is a change in kinetic energy. This is change in kinetic energy. That's how it came. That's how it came. It is telling you that it is a change in kinetic energy. Now let's see. So here, as we know, we wanted to know what is the relationship between work done and kinetic energy. You can see, as you know, work is what? Meaning of work is what? Force multiple displacement. I wrote force multiple displacement, and here we can substitute formula of force. What will be? Mass multiple A. I wrote mass multiple A as solution. A solution is which means a displacement. Displacement. So from equation of a motion, we found is displacement. We got this much, and here A get cut, and now here we got this. This is a relationship. Now it is telling you. It is telling you what this. This is telling you change in kinetic energy. This is what is it telling you. Now we are going to explore potential energy. We will see formula, meaning, and something else. Something else. Here, from definition of a potential energy, you will realize what? From definition of a potential energy, you will realize if a object is at height, this is object, and this is ground, and this is the height. This is the height of this object. Now you can say if there is a height of object, it means that object has potential energy. That object is ready. This object is ready to be in motion because it is at height. It is at height. That's why it object is ready to be in motion. Okay. Now here, what is happening? This force you can see. When this force will be fall, when this object will fall downward, which type of force you are observing? Gravitational force. Gravitational force. You would say downward force. Downward force. And this earth will apply upward force. Of course, this is force that you are observing here. If an object is at a height, and now object is, of course, it is ready to be in motion. When this pole will fall, then there would be gravitational force, downward force, and earth will apply upward force. So here relationship between potential energy and work done, what will be? What will be? As you know, formula of work would be what? F multiple S. Here this force, we are talking about this force. We are talking about this force. Our context is this. Try to understand. Our context is this. Here, which type of force are you utilizing? Of course, gravitational. That's why here already this is a mass. Okay, this is mass. And we have what G, which is a gravitation. Gravitation. Now it is a force. It is force. Force is on. Force is on where? This. It will fall because of gravitation. So we will consider this mass. We have this. You would say, why not A? Why not A? A, because according to force, which force are you realizing? Gravitation. That's why we applied G. Now here we will substitute F, formula of F here in this. What is mg? Now S, which means displacement. Displacement is what here? This is a displacement. It means h. We will consider this as a h. Now this is a displacement. This is a displacement. Distance, shortest displacement. So S, we are considering h. Now you got a relationship. You got a formula of potential energy. Now you got a formula of potential energy, mg multiple h, and formula of kinetic energy is what? 1 upon 2 mass multiple v raised to power 2, and formula of potential energy will be mgh. mgh, clear? Where force is gravitational, and h is a displacement. Clear? Here remember, object is here. As you know, gravitational force will depend upon height, isn't it? That's why we are able to consider this type of a force as a gravitational, because there is a height. That's why. Now here you can see this is at a height. That's why here we would say potential energy. It has full potential energy. It is ready to be in motion. Now it is coming like that. As it will come to ground, then here, just before here, it will have full kinetic energy. But when it will lie when it will be on the ground, then we can say it is what? Potential energy is 0 and kinetic energy will be 0. Kinetic energy will be 0 and potential energy will be 0. But just before it has a full velocity, here is a what? Here velocity is very high. Here velocity is a maximum. Here velocity is a maximum. Here velocity is 0, and here just before the ground, velocity of this object will be maximum. Here will be medium. Okay. Here potential energy of this object has maximum, but here potential of this object will be minimum. Clear? And this at height potential it will have kinetic energy. Now, let's take a real example to understand kinetic energy and potential energy, in which we will understand velocity. What is the kinetic energy? Where is the potential? Where is the potential energy is equal to 0? Real example. Here it is a ground. It is ground. Here a person is here. it is throwing. He is throwing ball. He is throwing ball like that. Now ball came here. He thrown ball upward. Now when ball will be ready to come downward at the top, now till here, now it is ready to come downward. Here we would say velocity is 0. Velocity is 0. Here velocity is 0. And now what is? Kinetic energy will be 0. Kinetic energy will be 0. Because it is at the top. We are considering it is that it is at the top. It did not start move. That's why kinetic energy at the top will be 0. But what about potential energy? Maximum. Because I told you that it is ready. It is at the top. It will be ready to come downward. If it is ready, it will be coming downward. It means it will move. Now it is moving. We can say it will have what? Kinetic energy. So that's why we are saying it has right now it has a maximum potential energy. But it didn't start move. That's why we are saying right now it has what? Kinetic energy, and kinetic energy is equal to 0. Kinetic energy of this is equal to 0. Clear? And now here you can see height. You can observe height. Let's say 15 meter. Let's say 15 meter. This height is 15 meter. Isn't it? Height is 15 meter. You are able to observe height. Now we know that this height can be considered as displacement. It is a potential. We are finding what potential. If there is a height of this object, we can easily say object which is at height, that object will have. It means object has potential energy because it is at height. That's all. Now it is ready to come downward. If it is at the top, now velocity of this is 0 because it is not moving. That's all. In simple, you can say it is not moving. It means velocity is 0. Are you understanding? Now, as ball is released from here, now what will happen? We saw that if a ball is at the height, then this will happen. Kinetic energy will be 0, potential energy will be maximum, velocity is 0 when it is at top. It is at the top. Now ball is being released. Now it is coming, it means it is coming. If it is coming, it means now you can see it is a gravitational force, isn't it? Now it is coming downward. If it is coming downward, so here gradually the speed of this is increasing. Velocity of this is like that is increasing. You see in a real life. When something is coming from a sky, then immediately that object will hit on earth very heavy because because of velocity was high. As it comes near of the earth, just just before earth, velocity of object remains high. Okay, that's all. If height of object will be less, then impact, then that object will hit less on earth. If height of the object will be more, then you can see velocity will be more. Just before ground, velocity will be more, and that's how that object will hit a very heavy on surface of the object, because of velocity is more, because of height is more. Height is more, that's why velocity will be more. If velocity is more, it means it will hit a very heavy on surface of the earth. Clear? Now it is a moving, it means it has kinetic energy. It has kinetic energy. Okay, yes. Now here, just before ground, we can say velocity is a maximum. Velocity is a maximum just before ground. When it will be on ground, then we would say velocity became zero. Velocity became zero. Here we are not taking a speed, because a speed we take not a speed we take when we don't care about the direction. But here we need a direction. It is coming downward. This is a direction. That's why we have taken what? Velocity. Okay, velocity. And it has a displacement. Now here it this potential energy converted converted into kinetic energy. Remember, because here it is moving, now it has the kinetic energy. Clear? Clear. Now here, as you know, formula for potential energy would be what? It is a gravitational. It has a mass, gravitational, and this height. By doing that, by using this formula, you will get potential energy. You will get potential energy. Just put mass of this object, and what is this gravitational force, and what is the height, 50. You will get potential energy. This will tell you what was the potential energy of this here. This is what you will get. Okay. Now here one thing is a universal truth. Always remember, kinetic energy and potential energy would give you constant. Just remember it. Here, if velocity is more, it means kinetic energy will be more. Because as we saw, if Kinetic energy will depend on velocity. If velocity is more, it means kinetic energy will be more. Here you can see velocity is less, it means kinetic velocity is less. Here you can see meaning of this would be kinetic energy is less. Now here velocity is more, so of course kinetic energy will be more. We saw in the discussion of kinetic energy. Remember, on this. Clear? Now some of these both types of mechanical energy will give constant. Now next. Next law of conservation of energy. This is law of conservation of energy. Next we will understand power. This is what we will discuss now. Look at this. What is the law of conservation of energy? Here we are talking about conservation. How to convert energy from one to another. This is law. This is property, you can say. This is a rule of conservation of energy. First point, always remember, it cannot end. It cannot be created. It cannot be destroyed anyhow. Even you cannot create energy. You cannot destroy energy. Okay. A object will have some energy. A object will have energy, but we cannot say that object does not have energy. Same here, it is saying energy can be only transformed from one to another. From one to another. Okay. Only it can be transformed. As we saw, if we apply force on other object, then energy of me will decrease. Now energy of that object will increase. So here energy is transforming. Energy is converting from me into this object. This is a law of conservation of energy. When you will apply force on object, then your force, who will gain? Object will gain. Object will gain your gain. And this process we say this is a conservation of energy. Energy can be only transferred from one form to another. Second, this is the next concept. This is the next concept, which name is the power. From what you can observe, what will be the meaning of the power? What will be the definition of power? After this, we will understand work again. A little information we will discuss on work done. Let's understand this. Work will tell you, work will explain that it is what? It is a rate of doing work. Okay. How much work are you doing within a certain time? Within a certain time. If you are able to work within a few seconds, you are doing work more within a few seconds, then it means your power is more. With the example, this is one. Okay. Here, mass of both. This is object. This is object. Mass of both object is the same. Okay. Now both are lifting the objects. Both are lifting the object. It means both are applying force. Now this first A and this B. First lifted this object within a 3 seconds. Within a 3 seconds. But this person did lift this object within a 5 seconds. Why like that? Why is it happening? Because of power. Because of power. It is lifting like that slowly. Oh, this is lifting slowly because of power is less. He is applying less power. He is applying more power. If he is taking more time, it means he is not applying more power. If he is taking less time, it means he applied more power. So power will tell you what is the rate of doing work. He is also doing work. He is also doing work. But he lifted object within a 3 seconds, and he lifted this object within a 5 seconds. From here, we are able to identify what power. What is the rate of this 2% of doing work? You would say he did work within a 3 seconds. He did work within a 5 seconds. It is the rate of a doing work of a rate of a transform of energy. Then sometimes you utilize power, it means energy. He is applying less energy, that's why. So otherwise you can say if he is applying force object, it means of energy of this person will decrease because he applied force on this object. But here transformation time of a transfer time of a transfer of energy is less. Okay, both are applying, but within a less. This is applying by taking more time. No. Now SI unit will be what? Watt. Okay, watt. Clear watt. This is the SI unit of power. Just W upon T. Just W upon T. Work done. Both are doing work, and how much time they took. That's here time. Now here. This is a done. Work. What is the definition of work done? According to you, you would say it is a what? Force and displacement. We will apply force, and that object will displace because we applied force. Now we can say we did work. If there is a displacement of object and we applied force, now we can say that it is work done. We are applying, in other case, if we are applying force, but object is not displacing. If object is not moving, it means work done is 0. Remember. I know, you also know. We applied force. What about this? We will not care about it unless both will cover both this, but displacement and force. If force is 0, it means object will not move. If force is more, object can move, object cannot move. Okay, it will depend on situation. What is the situation of that object? If friction is happening with that object, then we will say that work is negative. Work done is negative. So always remember, meaning of work done will depend on mass, force and displacement. We will have to apply force, and then object should displace. That object should have displacement after applying external force. Clear? So from this definition, we can say W will be equal to a force and displacement. This is a small s. Force multiple displacement will give you work. Yeah. Now types of work done. What about this? Yes, there are 3 types of work done. First is positive, second is negative, third is 0. If you are applying force and object is moving towards, then you can say work is positive. If there is no friction, then you are applying force, you are pulling object. If you are pushing object, and object is moving towards, then that work is positive. If you are applying force and you are pulling, okay, you are pulling object and object is coming to you. Now which work? Is work zero? Is work done negative? Is work done positive? Work done would be positive, because pull and push is just a force. That's why. If friction is not coming, then if a friction is not coming, then now in third case, in third case, you are applying force, you are pushing object. Now there is a friction. Friction, work of friction is to stop, is to give opposite to force. Friction will stop the object. Friction will block the object. Okay, if a friction is happening, if a friction is blocking the object, it means this is a negative work done. Work done is a negative, because of there is a opposite force which is being applied by friction. Clear? Work done zero, it means you didn't work. Displacement would be zero. Displacement is zero, then you would say work done is zero.